Hello everyone. If you're a data scientist or data analyst and looking for adding a new library which can help you in data manipulation and analysis, then you have clicked on the right video. In this video, we will discuss polars in detail. To get to know about this library, we will be discussing only the theoretical aspects, and in other videos, we will see the detailed implementation of it. So when we talk about data manipulation and data analysis, we always think about pandas because pandas is the most commonly used libraries. Panda library is an open source and it has a large ecosystem and a huge community. It is one of the most standard library and has a very stable API. But there are certain limitations of using pandas when it comes to working with a large data set. It is very memory intensive. This means that when we are dealing with large data set, pandas can quickly consume a significant amount of our system's memory. This happens because pandas typically loads all the data into memory, which can lead to performance bottlenecks, slow processing times, and even it can crash our system out of memory. The other limitation of pandas is that it works in a single threaded mode by default. This means that when we are performing any operations, all the data pre-processing tasks are executed on a single CPU core, which can significantly slow down operations, especially with larger data set. The other issue with pandas is that like it has a limited scaling. It lacks built-in parallelism, which means that it doesn't natively distribute tasks across different multiple cores or processes. As a result, when working with complex or large data scale data pre-processing, we may find that pandas struggle to keep on and leading to much slower performance and longer processing time. But when we talk about other libraries like PySpark, the problem with them is that they have a complex API, and it's clear that it's known that they are powerful tools for handling large scale data. But the challenge is the complex API, and which can also quite create a kind of a steep learning curve, and it can be overwhelming for the newcomers to understand the syntax and the programming aspect of PySpark. Okay, so comparatively, pandas and polars are much simpler with respect to PySpark. So these are some of the disadvantages, or you can say, of using of using pandas and PySpark. Now, next thing is, let's talk about polars. Okay, so So Polars is a library which is being developed for the purpose of data manipulation and analysis. So it has an exceptional speed and efficiency. Uh, the main objective behind Polars is to enable fast data processing by leveraging multi-threaded parallelism. Additionally, it uses the arrow memory format, which significantly boosts performance by ensuring efficient data storage and access. Polar is an excellent alternative for handling large data set and big data application. It's optimized to manage vast amount of data that would typically be cumbersome in other libraries like Pandas. Polars is being written in Rust. Polars not only support Python, but also extend its capabilities to other popular programming languages such as R and Node.js, making it a more kind of a versatile and adaptable to various programming environments. Then this was kind of a project which was being developed by Richie Wink, and it was a kind of a personal project, and it gained a lot of attraction due to its impressive performance and scalability. It's now quietly becoming a preferred choice in the field of data science community. Lastly, the Polar stand out with its simple and stable API. It's easy to learn and implement, and it's user friendly also, which allows us to perform different operations on different types of data structure and different data types. Um, Now we will look into the features of Polars. When working with large data set, Polar utilizes all available cores on our machine and can significantly speed up processing. So let's say we are processing a huge CSV file. Instead of using just one core, this library splits the workload so that each core processes a part of the data simultaneously. This means it can create a faster processing environment and without doing any extra effort. Next thing is about efficiency. Efficiency is key. By being memory efficient, this library ensures that our data is stored and processed in a way that uses a little memory as possible, preventing our machine from slowing down. It uses the RAM memory wisely, just like how to compressed files save space on the hard disk. One of the other key feature of Polar is lazy evaluation. So when we say lazy evaluation, it's a smart way to optimize execution. Instead of rushing to compute everything at once, this method delays computation until it is absolutely necessary, saving both time and resources. Imagine we have a list of numbers and we want to find the first odd number. With lazy evaluation, the process stops as soon as it finds the number rather than scanning the entire list. The other characteristics of Polar is that it supports multi-threading. Multi-threading is possible by leveraging your multi-core processor. This means uh, that any operations is being run on multiple threads in parallel, each handling different parts of our data pre-processing task. If we are filtering, sorting, and analyzing data at the same time, each of these tasks can run on separate threads, making the entire process much quicker and faster. Polars follow strict schema for the data types. A strict schema means that the data type should be known before running a query. A strict schema means that it ensures that the operations are consistent and errors are minimized. So before we start processing, if our data set requires integer in one column and strings in another, the library checks this for us to avoid any issues later on. This library integrate well with other powerful libraries which are used for data manipulation and data analysis. They are Pandas and NumPy, which allows us to leverage the best of both the worlds when it comes to any kind of an operations. Let's say we are using Pandas for data analysis and NumPy for numerical calculation. This library works alongside them, which can help us in letting us switch between tools without breaking our workflow. Um, the other great characteristics of Polaris is that it reduces the redundant copies, which means that the data is only stored or processed once, minimizing the waste and maximum efficiency. If we are working with a large data set that we need to transform, instead of creating multiple copies at each step, this method ensures that only necessary transformations are kept. And finally, processing data in chunks allows us to handle massive data sets that wouldn't fit in memory all at once by breaking them into smaller, manageable pieces. When loading a huge file, instead of trying to load it all at once, which could crash our system, we load and process it in smaller parts. This way, our machine handles it smoothly, no matter the size. So this was about the features of the polars. Now we will talk about the difference between polars versus pandas. So we know that why we are comparing the polars and pandas. The reason is that pandas is the still the most widely used when it comes to the uh, when it comes to data manipulation and analysis, because pandas has a larger market share still. So and it has a very huge open source community. But polars is growing, but there are significant difference between both of them. So the first step is when we talk about the parallel processing. Polars is designed to take full advantage of our machine's capabilities by using parallel processing. This means that it can spread the workflow or workload across multiple CPU cores, handling in larger data sets more efficiently. Just imagine that we have a huge data set and want to filter rows based on a condition. Polars process these rows in parallel, making the operation much faster compared to pandas, which processes data sequentially on a single core. Next is about memory usage. So when it comes to memory usage, Polar is much more memory efficient than Pandas. It's optimized to use less memory while processing large data set, which is crucial when working with limited resources or huge data. Think of it like this. Polar compresses our data more effectively so we can work with bigger data sets without running into memory issues, whereas Pandas might struggle with same load. Next is we will look into the API methods. Polars and pandas, to be honest, offer similar functionality, and but their syntax and API design differ. Polar provides a more concise and expressive API, which can sometimes be more intuitive. especially for complex data transformations. Polars have a more concise API, and Pandas has a more familiar API because of its large market share and a huge open source community. Next is which is the big major difference between the polars and panda is the lazy evaluation. Lazy evaluation is another area where polars shines. Unlike pandas, which compute results immediately, polar delays execution until absolutely necessary. This can significantly speed up operation by reducing unnecessary computation. Imagine chaining multiple operations together, like we are doing filtering, grouping, and aggregating data together. With pandas, each operation is computed step by step, but polars wait to run all operations at once, optimizing the entire process. We can say Polar supports lazy evaluation and Pandas has eager evaluation. The next difference is related to the size of the data sets. Polar is particularly well suited for large data sets. Its parallel processing and memory efficient allows it to handle bigger data set with ease, whereas Pandas might struggle as the data size increases. Consider working with a dataset containing millions of rows. Polar processes data smoothly, while pandas might hit memory limits or slow down significantly. And in this situation, we have already seen when using pandas is that we get something error called as a memory error when we are working on our Jupyter notebooks. So we can say in a simple words that Polar is much more better suited for a large data set, but Pandas is better suited for a small to medium data set. Now, next step is talking about the Polar installation. So the most simple way of installing Polar is like whether you are doing any kind of a environment, you can just type pip install Polars and the Polar is installed. Let's say you are using Anaconda. Okay, so you can go to the Anaconda command prompt, just type pip install Polars, and it will be going to install the Polars for you. We can also install polars with using this command in the Conda environment. You can use this Conda install, Conda forge, and then polars. Okay, it's going to install the polars in your Conda environment. And this pip install polars can also be used if you're using any kind of an IDE with a Python environment. So you can use this pip install polars for installing it. If you want to install a specific version, because sometimes there's a need that we need a specific version which can be compatible with other open source libraries. So then in that case, you can use pip install polars equal to the version in which you want your polars to be installed. Next is if you want to install it directly from the source, from the GitHub repo, so you can just do git clone and repo the original polars GitHub repository, and then you can just go to the polars bipolar the path, and then you can just do pip install. So this way you are going to install the we can install the polars. Next thing is what are the data types supported by polars? So the polar supports data which are numerical in nature. When I say numerical, it's decimal, integer, float, unsigned integer data types. It can also support temporal data types. So temporal here refers to the all the and data types which are in the form of date or time. So it can support functions like date time, duration, time, anything which is time related. Then we can have support of nested data types. When I say nested data types, it can be a kind of a data structure like array, list, or struct. It also supports string. So string can be in the form of a normal string, or it can be in the form of a categorical or enumeration. It also has a support for a kind of a binary, Boolean, and null and objects type of data. What are the data structures supported by polars? So polar supports data frame, which is most commonly used. Everybody knows about the data frame, just like pandas support data frame. And what is data frame? Data frame is basically a tabular data which is two-dimensional in nature, which has rows and columns. So it's being supported by polars. The other thing is the series. So series is basically we can say it is one-dimensional. It's a kind of an array-like structure that holds the data of a single data type. So let's imagine we have a data frame. So one column of that particular data frame can be considered as a series. The next thing is the LazyFrame. So it's just a kind of a data frame. So, but it is a kind of a deferred execution version of the data frame. This is executed only when needed. Next thing is like when we already know that that Polar supports data frame LazyFrame, and series. So now we are going to look into the different methods which is being supported for all these three types of data structure. So when you talk about DataFrame methods, it supports aggregation methods where we can perform the operations of sum, count, mean, medium, etc. on a particular column. Okay. Then we have the attributes type. So attributes type is going to give us the name of the columns, DT types, what is the height of the height and the shape of the columns. Shape will give you the number of rows and number of columns. So basically, if you want to know about the attributes, methods are basically when we are using doing a kind of a data exploration. Next is the computation methods. So computation methods can be many type. It can be fold and hash rows. Then it also supports descriptive methods. Descriptive method is to describe, is to get the 5-point summary or descriptive statistics of the data. Is there any unique value? Is empty and unique? And there are so many methods there. Then we have the export method. So export method is basically when we how we can convert the data frame, which is when we create a data frame, it's in the form of a polar data frame. Its data type is polar data frame. So we can convert into other formats. Other formats can be, we can convert into a kind of an arrow type, into a form of a CSV, or into a form of a JSON, or it can we can store convert it into any different format. Okay. Then is the group by data. So we can group our data by one or more columns. Okay. So basically, when we are using any group by methods, uh, group by methods are mostly used along with the aggregation methods. Then we have the manipulation and selection methods, which is helpful in data manipulation and selection. So selection is based upon like if we want a subset of data, so there should be some logic behind it, how we want to our subset of data. So all these things, all different methods are being used here, can be used for the purpose of selection. Then there are some miscellaneous methods also, like if you want to get the schema of the data frame, what is the correlation between the different columns, we can perform the lazy query, etc. And then also the polars data frame methods also has a plot method which can help us in creating a visualization chart. So this was all about the data frame methods. Next is the lazy frame methods. So lazy frame methods are also, because we know that lazy frame is basically a kind of a data frame which has a deferred execution. So it is also have the same kind of methods. It has an aggregation methods, attributes methods, descriptive methods, manipulation selection methods, miscellaneous function, then group by and in process query method. Okay, for the purpose of doing the execution. Okay, so next is the series method. So series is basically a kind of, we can say, a one single dimensional array, or it can be a one column of a particular data frame. So here also we can perform different methods for aggregation, different array methods. Array, when I say array methods, which means that that particular series contain data which is in the array format. So in that case, we have some built-in array methods which we can perform on that kind of a data structure. We have the attributes method, just like the data frame and the lazy frame methods. We have the binary methods, Boolean methods to check the true and false conditions based upon different conditions which is mentioned in the code. Categories, computation methods. So computation method here contains the mathematical functions like trigonometry, linear algebra, and other methods. Then we have the descriptive methods. Descriptive methods here is the what is the length of the chunk, summary statistics or 5-point summary, then missing values, unique values, etc. So these are the methods which is being supported in series. It has other methods also, like export, like how we can format the series into different data. We can convert them into a kind of a JAX array, Panda series, n-dimensional array. We can do it in the form of a PyTorch tensor, Python list. Then there is a list methods also. So when sometimes is like these are the methods to handle list data, which is represented in the form of a polar series. We have manipulation and selection methods, miscellaneous methods, like how to check that if the two series are equal, how we can map the elements, how we can sort the elements. Then it also supports the plot for data visualization. Then we have the string methods, which are basically the methods for string data represented in the form of a series. Then struct method for the struct series. Then we have the temporal methods, which is basically all the methods which is related to the time attributes, like date, date time, epoch, hour, etc. Then we also have polar expressions and selector methods. So expressions are basically, when we talk about the polar expressions, it talks about how we can how we can perform complex operations in a more declarative and efficient manner. So basically here what when we will look into the code, we will see that the code is being expressed in is being designed in the form of an expression. So it becomes much more easier to read it and to understand what kind of operation is going on. So it also supports methods like aggregate, array, binary methods, Boolean methods, categories, and computation methods. The most important thing about the expression is that it has a support for the Windows method. Please remember it has support for the Windows methods. And these Windows methods are just like the same methods which we use in our SQL. So like ranking, rank, row number, and hover on all these kind of methods. Okay. Selectors are also a kind of an way of these methods allows us to do a kind of an intuitive selection of columns for data frame or lazy frame based on their name, type, etc. We also support for the set operations like union, intersection, indifference, etc. And some of the methods are also like call, all, exclude, first, last, count, and etc. The other methods are there are some other methods which is being supported. One is the input and output, which helps us in reading and writing the data in different formats. Like the data can be in the form of an Avro, CSV, clipboard, database, Excel, JSON, or Paraquet. It also supports SQL interface. Polars has an SQL interface which supports all kind of SQL clauses, functions, and operations. We also have some kind of a configuration methods which can adjust the setting and behavior of the library. Uh, then there are some conversion methods to create or construct data frame from different data formats like array, dictionary, pandas, data frame, etc. It also supports parallelization methods to collect different multiple lazy frames at same time synchronously or asynchronously. Now, this was about the polars, but there are certain challenges also with polars. Now, when we talk about polars is still new in the market. Okay, still most of the projects are using pandas because pandas has a better compatibility with the machine learning packages like scikit-learn and other deep learning models. Polars doesn't have much better compatibility as compared to the other machine learning models. So this can leads to be a problem, leads to be a unstable behavior. But I think that in the coming time, Polars will become much more go-to library as compared to Pandas because it's going to be more stable. Uh, and we also see that the API is stable, but since it has a frequent releases, so what happens is like every time the code syntax is being changed, and this can lead to the breaking of the code in the existing projects. The other challenge is like since they have frequent releases, so documentation, user guide, tutorials to learn Polars needs to be frequently updated so that everybody can catch up with what's going on in the latest. The Polars doesn't integrate well with the big data tools like Apache, Spark, or Dask, as compared to the Pandas. Okay, so this is also one of the drawback, but let's see in the future we can have a better version of Polars. It does not have an extensive support for time series analysis, so this is also a issue. But I think day by day it will work more. So if you have any questions, please write it down in the comment section. And thanks for staying with me for this presentation. Um, and if please do comment and please subscribe to my channel. Thanks a lot.